Hello everybody. I've created this video to walk you through the NIM game, which is one of the assignments that you have if you're in one of my CIS 116 or CIS 123 sections. This is a program that I've implemented, or I will implement, in Ruby. And what I have here is RubyMine, and I have the file that I've created here, nimgame.rb. And I'm going to go ahead and start. And what I'm going to do is, first of all, put the comments in, and then I'll actually write the code around the comments. So first of all, we need to create a set of pile counters. There's 3 piles, 5, 4, and 3 sticks are in each pile, so we need to set that up. Then we need to get the first player's name and the second player's name. Then what we need to do is we need to create a turn counter that tells us which player is playing. And I'm going to just say set the turn flag to the first player, so we know which player is up to bat. So what's going to happen is there's going to be a loop here that continues as long as more than one stick exists. So we just add up the number of sticks in each pile. As long as the total is greater than 1, we keep going. And inside of our loop, player 1 gets a turn, player 2 gets a turn, and then player 1 and player 2, and it just keeps going like that until the person who's left with 1 stick loses the game. Inside of our loop, the first thing we need to do is display the pile counters so the user knows what's going on. And we need to get the pile choice from the user, and we need to make sure it's valid. So I'll actually put here get valid pile choice from user. And then once we've done that, we need to get a count. Get valid stick count from the user. And then once we have that, we can then simply remove the sticks from the appropriate pile. And then at that point, we should check to see if the game should continue. If so, we want to switch the flag to the next player and then end our loop at this point. So once our loop is finished, we will display the winner and loser. So that's basically our pseudocode, or essentially a list of steps that we need to implement for the game. Now, there are many ways to build this game, so this is just one approach. If you have a different approach, that's totally fine. Many ways to do this, but I'm going to start here now with my very first step up top. And so I'm going to come up here and I'm going to begin by creating an array of piles. So I'm going to create an array called piles, and it's going to equal array. I have 3, 4, and 5 sticks. Element of 3, element of 4, element of 5. That's my array of piles. Now I have 2 players. Let me get the first player's name. Okay, so I'm going to print player 1, enter your name, and I will create a variable called player 1, set it equal to get s.chump. Then I'll do the same thing for the second player. And then, because I'm using arrays for the piles, I'm going to use an array for the players as well. So I'm going to say players equals array, and then I'll put in player 1, player 2. So those are my players in an array now, the names. Then I need to set a turn flag to the first player. So I'll say current player is equal to 1. And then I'm going to begin my loop. And all these comments I'll put inside of the loop, and then the loop will end here. It will keep going as long as keep playing is true. So I need a variable called keep playing, and I'm going to initialize that variable at the very beginning before we go into the loop, which is called a primary read. So we create our piles, we get the first players and second players' names, we store them in an array, we set the current player flag to 1, we set our keep playing Boolean to true, and then we enter a loop that continues as long as keep playing is true. I'm going to set current player to 0. Instead of 1 and 2, let's make it 0 and 1. You'll see why I'm going to do that here in a little bit. Now in my loop, to display the pile counters, I can simply put S and then a carriage return A colon, and then I'm going to put in piles sub 0. Now I'll do a tab out, B colon space piles sub 1, piles sub 2, and a couple of carriage returns after that. So it looks very cryptic, but basically we have a carriage return, A colon space and a number, piles of 0, a tab, B colon space and another number, tab, C colon space and another number, and 2 carriage returns, the numbers being the 3 values of items or sticks in each pile. Now it says get a valid pile choice from the user. Now what I'm going to do here is create a variable, a boolean, called pile is valid, and I'm going to set it equal to false. And what I'm going to do is I'm going to ask the user to give me a pile choice, and I'm going to assume they screw up. And if they screw up, I'm going to repeat the process. So to do this, I'm going to make a loop. And this loop is going to continue until pile is valid. I'm going to do the same thing for the count question that comes after that, in which case once they've chosen the stick, then they tell me how many items they want to take out. I'm going to call that count is valid, and it's going to be the same type of approach where we keep going until count is valid. So in our loop, I'm going to ask the user, I'm going to ask them to choose a pile. So I'm going to print players sub current player. Now because it's 0 based, this will be players sub 0 if the first player is up, and players sub 1 if the second player is up. So it's gonna put their name in based on the index to the array. So to put their name, then it will say, comma, choose a pile, and wait for their response. And then I'll do pile choice equals gets.chomp, and then I'll upcase it so that I don't have to worry about case. Whether they type upper or lowercase letters doesn't matter. Now I need to make sure the choice is valid. So I'm going to say if pile choice is equal to A, pile index equals 0. Else if pile choice equals B, then pile index will equal 1. Else if pile choice is C, then pile index will equal 2. Otherwise, they gave me something invalid. So I'll put out onto the screen, invalid choice. You must enter A, B, or C. And then I'll set the pile index to -1. Depending on what they give me, whether it's A, B, or C, I'm going to set an index. Else, I'm going to tell them they screwed up, ask them to enter again, and they go back up. Now, once I've done that, I'm still not out of the woods, because just because they choose A, B, or C doesn't mean they're okay. They have to pick a pile with sticks in it still. So I need to say this. If the letter is valid, but the pile is empty, the user must choose another pile. So it's basically two things you need to do to validate the pile choice. One, make sure it's A, B, or C. And then two, when it is A, B, or C, make sure that there's sticks in the pile they want. So I'm going to do this. If pile index is greater than or equal to 0, I'll just say this, it's greater than -1. In other words, they made a good choice. If piles sub pile index, which is going to give me the number of sticks in the pile, if that's 0, they chose a bad pile. So I'm going to put up a text message that says, nice try, comma, players sub current player. That pile is empty. Choose another pile. Couple carriage returns. And now, else, if they picked a pile that had stuff in it, that is the thing that unlocks the loop. Pile is valid, is true. That line 47 is the key out of this infinite, not infinite, but it's the key out of this validation loop. So this loop, which starts here and ends down here, will continue and go back and continue over and over and over until they enter A, B, or C, and then there's something in the pile they chose. So that's my validation loop for the pile choice. Now I need to do the same thing for the stick count choice. So again, in this next section here, I'm going to print out how many sticks do you want to take from pile choice, which will be A, B, or C, question mark. And I'll give them a space there. And I'm going to create an item count equals gets.toI because this is a number. Now I need to make sure the count is between 1 and the max value for the chosen pile. Basically what that means is if they pick a pile that has 4 items in it, the number has to be between 1 and 4. So first of all, let's check to see if item count is less than 1. That's obviously not going to be good. If that happens, we'll put a string up that says you must choose at least 1 stick. Another possible scenario is the item count is greater than pile sub pile index, which is saying they're trying to choose more sticks than there are in the pile. And if that happens, we will put up a message that says pile choice doesn't have that many sticks. Try again. The other possibility is that they pick all of the sticks in the pile. Now, this is okay to do unless they take all the remaining sticks, because you don't want the user to take all of the sticks that are left in the game. That's actually a loophole, because if they do that, no sticks will be left. The loop will exit, and they'll be declared the winner of the game, and that's not accepted. We can't let the user pick everything out. So we'll need to make sure that they leave at least 1 stick left. So if the item count is equal to piles.sum, so in other words, if we take and add up the number of sticks in all the piles, and that's the number that they choose, then there won't be any sticks left, and we don't want to allow that to happen. So I'm going to put S here, a message that says you cannot take all the sticks, or you will lose. You must leave at least 1. So we need to close up that loophole, basically. So if that isn't a problem, then count is valid will be set to true. And that essentially then takes care of the validation loop for getting the stick count, which is this section right here. So now we have asked the user for the pile, we've asked them for the number of sticks to take out, we've checked to make sure that everything's cool, and now the easy stuff. That was the hard stuff. Now what we do is we go to piles sub pile count, or sorry, pile choice, pile index, get it right. So we take the appropriate pile and we subtract out the number of sticks from that pile. Now we need to check to see if we should keep playing or not. Keep playing is going to be set equal to piles.sum greater than 1. Basically, we're going to add up the total number of sticks in all 3 piles, and if the total is greater than 1, then we're going to let the game continue. If not, we're going to exit, and the game will be finished. Now, if it's appropriate to keep playing the game, then I'm going to switch the player. And this is what I'm doing it here is I'm applying a logical OR to this value, which basically what that's going to do, it's going to toggle current player from 1 to 0 or 0 to 1. If current player is 0, this will make it a 1. If current player is a 1, it will make it a 0. But we don't want to switch players if the game should end. So if the player got the game into a situation where there's only 1 stick left, they are essentially the winner. So we're not going to switch players if that's true. What that means is that out of the loop here, the current player will be the winner. So to display the winner, I can put up here players bracket current player, comma, you win. So that's it. Okay, let me go back now and take a look at the entire thing. So I create a set of pile counters, an array of piles 3, 4, and 5. I get the first player's name stored in a variable, get the second player's name stored in a variable. I take it and create an array with those 2 names called players and set them up. I create a current player variable that is either 0 or 1, depending on the player who's up to bat. I prime my loop with a variable called keep playing, set it to true, and go into my loop. I display the pile counters. I ask the current player to pick a pile. I get their choice. I check to see if it's A, B, or C. If it's not, I tell them. Then I take a look at the number of sticks in the pile that they've selected, and if there's nothing there, I tell them. Otherwise, it's an inappropriate pile to choose. And so I clear that. This loop will come back up and repeat until both conditions are satisfied, in which case I go to the next step, which is to get the stick count. So I ask the user how many sticks they want. I get the count. I make sure it's not 0. I make sure it's not greater than what's in the pile. And then I make sure that they're not taking all the remaining sticks out of the game. And if none of those are a problem, then I set this flag to true, which gets me out of this validation loop. And now I have a count that's valid. So then I go to the array of piles, index the appropriate pile, take out the number of sticks from it, check to see if the total number of piles is greater than 1, and if it is, I keep playing. If I keep playing, I switch the player from player 1 to player 2 or backwards the other way, and then this loop picks me back up, and the whole process starts again, and the next player takes their turn. So normally I would never write a whole program like this and just run it. I would do it in pieces and run each piece, but I'm going to save this and see what we get when I hit the run button. Pick Joe and Louise, and I'll start by using good data. So I'll pick, Joe will pick pile C, they'll choose 5 sticks, leaving pile C empty. Louise will pick pile A and they'll take 3. Joe will take B and choose 3 sticks, leaving 1 stick left, and Joe is the winner. So that worked. I'll try it again. I'll try picking pile D, invalid. I'll try picking lowercase c, that's good. I'll try picking 9 sticks from pile C, it's too many. I'll try picking -3, too few. I'll pick a good number, I'll pick 5. I'll have Louise pick from pile B and take 4, and then I'll try to see if this loophole is addressed. I'll have Joe choose pile A, and I'll have him try to take all 3 sticks, and it prohibits that. So that loophole is not there now. They have to pick a number, actually in this case 1 or 2. If they choose 1, they're not very bright, because that leaves Louise here, who can take 1 also, which isn't very bright either. Actually, that's not true. I'm sorry. If she takes 1, there's only 1 left. That is what she wanted to do. So anyway, yeah. Point is, the game seems to be working right. So the testing is important. You want to go through every possible scenario and make sure that you can't crash the game. So for example, I want to make sure, one more thing I'd want to check, okay? If they pick a number for a pile, that's not good. If it asks how many sticks do you want and they type in gibberish, the program doesn't crash. It interprets that as a 0. So you want to try invalid inputs just to make sure you can't crash the program. So that's the NIM game in a nutshell. And the only thing I haven't done here is put my comment block up at the top. So, the comment block, the best way to do a comment block is to put in a block like this with your name, the title of the program, the date. This actually should be fall. And the course, it's either 116 or 123. This is a description of the program, how it works, and the revision history. Of course, this is November 6th, being the initial creation date. So if somebody else came into this game at a future date and made a change, maybe they added a new feature or fixed a bug, they could put their date in, their initials, and what they did. So that's a really nice way of setting up a comment block for a particular program. So that's it for this video. Hope you find this helpful. If you have any questions or comments, let me know. Thanks for watching.